Hello guys, welcome to this class. In our last class, we talked about Coulomb's law and we talked about the interaction between two charges, right? So, in this class, we are going to be continuing from where we stopped in the last class. We said that Coulomb's law says that the force, electrostatic force between two charges is directly proportional to the product of their charge, that is Q1, Q2, and the square that is separating them, that the square of the distance separating them, right? Now this k here is the constant of proportionality. We know that k is the constant of proportionality of the equation and is dependent on 1 all over 4, are you getting it now, epsilon, right? And we know that the value for k is equal to 9 times 10 raised to power 9, and the value for epsilon, where is epsilon for free space, is 8.854 times 10 raised to power minus 12 Coulomb square Newton per meter square, right? So we know all this. Okay, now what if, let us talk a little bit about this epsilon, but we'll be going into detail on it when we are on dielectric. Note, are we getting it now? Are we getting this? This is what we call relative permittivity. Relative permittivity is equal to permittivity of the medium. Permittivity of the medium. Are you getting it now? All over the permittivity, are you getting it now, of free space. So we have relative permittivity to be equal to permittivity of the medium. Are you getting it now? The permittivity of the medium is given by normal A, right? Then permittivity of the free space is given by what? E naught, right? So from here, when we want to make this guy the subject of the formula, we just know that we displace this to this side, then we now have E to become what? That is epsilon. So the permittivity of the medium to become E. Are we getting it now? Watch closely what we want to do. Also, we have this right now, and we said that also in free space is the same thing, just that we replace this with naught, right? And here becomes k naught. Is it not? Alright, so what we want to do now, we want to derive a little expression. If we observe this equation very carefully, are we getting it now? We discover that we can replace this epsilon with what? With this. Is that correct? So if that is true, what we'll do now, if that is true, that means I can clean this place here. I clean this place here, then I replace it with what? Replace it with epsilon, right? Epsilon naught. Is it not? Now, if I now replace it with epsilon naught, when you take a very close look at this equation, are we getting it now? You will discover that we have 4 pi E naught here, and also we also have 4. Are we getting now? We have 1 over 4 pi E naught here, and also if I go up here again, I also have 1 over 4 pi E naught here. Are we getting it? So what happens is that since this 4 pi E naught, this 4 pi E naught here is the same thing as k, so which means everything that I just cycled can be replaced by what? K naught. Is that correct? So which means that this my guy here, K, will now be equal to what? K naught, right? Because I just replaced it with the equivalent, right? K naught all over. What is remaining here? A subscript arrow. Right? So we can just clean up everything and say that K is equal to K naught over E subscript what? Arrow. Is that correct? So this is the constant of the equation. A arrow is the relative permittivity. Sometimes it's called dielectric constant when you are solving problem. So we know that this value, the value for this is same thing as what? 9 times 10 raised to power 9. Why do we have to derive this equation? To get K for other medium might not be given, right? But through this equation you can get K for other medium. Are you getting it? Are you getting it now? Alright, so if we substitute into F, K, Q1, Q2 all over arrow square. Now this K here is now being replaced by this guy, so I can now clean it off, right? So when I clean it off, then I replace it with this guy here because they are the same thing. That's what we just derived just now. It now becomes K naught, right? K naught over dt. So this is when they give you a dielectric constant, but when you say in free space, we just use the normal Columbs law, right? Okay, so let us just go into some problems and begin to enjoy what we are going to do just now. Okay, the first problem here states that what is the magnitude of the Coulombic force between 2 point charges? Q1, we're getting it now. Q1 minus 2.00 microcoulomb and Q2 plus 3.5 microcoulomb, separated from each other by a by a distance of 15 cm to air. And what is the nature of the force? From here we know that Q1, we're getting it now, Q1 is equal to minus 2.00 and Q2 is equal to plus 3.50 coulomb, right? So the distance arrow is what 15 cm. Any complaint? Okay. So first of all, we convert this 15 cm into meter. That's when divided by 100 it becomes what? 0.15 meter. Any complaint? Okay. So if this is true, we use our equation. We know that F is equal to what? K naught. Because it happens in free air, right? So that's K. Q1, Q2. Just substitute directly, and that becomes, we know that K is what? 9.0, right? K is what? 9.0. 9.0 times 10 raised to power 9. Then Q1 here, you're getting it now. Getting it. Okay. You replace this thing by 0.15. So that's so here Q1 is what? So we ignore the sign there. In your textbook they put the sign, but there's no need because we are looking for the magnitude. So there's no need of putting the sign. So that'll be 2 And we know that micro means what? 10 raised to power what? Minus 6, right? Times 3.5 5 times 10 times 10 raised to power minus 6, right? Everything divided by the square of the distance, that's 1.5 square. So if you press your calculator, it's easy enough. You have an answer as F to be equal to minus, I'm sorry, there's no minus there. So you have F to be equal to 2.8, right? 0 Newton. We'll be solving some problems. There is no time to waste, but you should understand that the electric constant R, I'm getting it. That's called dielectric constant, right? All right. Okay. Now the first problem here is two identical coins separated by a distance of 2.5 meter in a large vast liquid are carrying identical charges. Meaning Q1 is equal to Q2, right? It's equal to Q1 is equal to Q2. It's equal to Q because they are the same thing, right? Now calculate the magnitude of each charges if the repulsive electrostatic force between them. Then now they give us F is equal to what? 40 Newton. And they gave us a dielectric constant ER to be equal to 92. So this is very easy. We use the second related equation, F over what? ER times Q1 Q2 over R square. In this case, Q1 and Q2 are the same thing, so it's equal to Q, right? So if Q1 is Q and Q2 is Q, that means Q times Q becomes what? Q squared. So we continue there. We make Q the solve of formula. Make Q the solve of formula. I already know that. Sorry, I wipe up everything. ER square to be equal to F, right? So if we move this thing to this side, then we have K naught Q to be equal to F times E R square all over K naught, right? So that Q square will be equal to F times E R square all over what? All over K naught. Sorry, K naught. So Q square equals the root of, right, all over K naught. So all we just need to do here is just to do what we call direct substitution. Just do direct substitution. When we do direct substitution here, we have our answer. We have here Q. Are we getting it now? Q here will be equal to the root of, instead of me putting F here, I put 40. The value of S is 40. Instead of me to put ER, I put 92 because instead of me to put R square, I am just substituting the values that is given in the question. Okay, 9 and 10 raised to power 9. If you press start in your calculator, you have Q to be equal to 1.59. You can approximate that, right? So when we approximate, Q becomes 1.6 times 10 raised to power minus 3 coulombs. Now, question 2 says find the number of electrons on each coin. Remember that Q is equal to NA, right? And if Q is equal to NA, that means A will be equal to what? Q all over N, right? Okay, so if E is equal to Q over N, that means, that implies that the number of electrons here, that means that E will be equal to 1.6 times 10 raised to power minus 2. Oh, sorry. I'm looking for the number of electrons. I made electrons on the formula. Sorry. Alright, so question II says find the number of electrons. We know that Q is equal to NA, right? Then number of electrons, N, is equal to Q over E. And from our surface right now, we know that Q is 1.6 and 10 raised to power minus 3. And the value of an electron is 1.6 O2 is 10 raised to power minus 19, right? So if we do this, we have the number of electrons to be 9.99 times 10 raised to power 15. But we know that it is important to present charges in whole numbers, so this becomes 10 times 10. Getting it now? To power 15 electrons. We have example 1.8. I'm going to be touching the deep concept. I think example 1.6 and 1.7 are easy enough. So let's talk about 1.8. There's two tiny balls of 1.52 milligram are suspended from a common point by a light insulated thread 20 meters away, right? Okay, 20 meters long. If they are assumed to be point charges of equal value that repel each other until they make an angle 15 degrees to the vertical, so they repel each other to a stop at an angle 15 degrees, becomes 15 degrees. This one also becomes 15 degrees to the vertical, right? So here it becomes Q1 and here it becomes Q2. Okay, calculate the charge on each ball. What you should understand here is that we know that the weight of the ball we add downwards, right, called mg, and at this side we have what we call T tension, right? Now where will the force of repel the repelling force, where will it act along? It will act along to the horizontal, since we move sideways, so the force will act along this side, will act along this side, right? So we need F will act along this side, their weight mg is acting down, then the force on the string is the tension, right? So how do we get this force? Because if we get this force, we can just make Q subject of formula because all other parameters are on ground. So when we get this force here, F, we can be able to solve for the charges. If we take away this part and zoom into it, we have something like this. Right? We have something like this. I have here to be T. We have here to be F. We have here to be mg. The same way, using the principle of transmissibility of vectors, this is F, right? So F can also be in this horizontal part. Then mg is outing that one, so it becomes mg. In that the triangle rule under basic O-level physics, I think so. Cleaning off this side, you can see the same thing. So this side now, are we getting it? This place here is 15. I mean theta here is 15, right? Okay. The theta here is 15. Theta here is 15. Then we know that the mass mg, the mass m, so that m, which is the mass, is equal to 1.52 milligram, right? So when we are converting, we convert the milligram to what? To kilogram, and we know that milli means something multiplied by 6, so that would be 1.52 times 10 raised to power what? Minus 6. That will be the mass, kilogram. Now when we want to find the weight, because mg is what we are looking for, this mg is different from this mg. This mg means milligram, while this mg means the weight, right? So mg will multiply by 10 to give us the weight, right? So that will be 1.52 times 10 raised to power minus 5 Newton. Now this is the value we have here. This is the value we have as mg. So what do? We use SOHCAHTOA, right? We can use SOHCAHTOA to resolve the effect to what? The horizontal component. And if we use SOHCAHTOA, we know that this facing this angle is opposite, this place is hypotenuse, and this place is what? Adjacent, right? So we know that the relationship between opposite and adjacent is tan theta. That means that tan theta, and here theta is what? 15 degrees, so that means tan 15 is equal to F over mg, where mg is what? 1.52 times 10 raised to power minus 5. Alright, so when we make F, so let the formula F will be equal to 1.52 times 10 raised to power minus 5 times 15, right? So when you press your calculator, you have F to be equal to 3.99. We're getting it now. 3.99 times 10 raised to power minus 6 Newton. So we have gotten the force from here. That's very easy. So since we have gotten the force to be 3.99 99 times 10 raised to power 10 Newton. Then the next thing we do is to write our equation. But secondly, before we write our equation, we know that the thread are suspended like this, right? And at this point, we have distance to be what? At this point, we have the distance to be 20 cm. So here is 20 cm. So we need to look for the related distance between the two charges, Q1 and Q2, right? So what we do, we already know that here is 15. It's all about trigonometry. We resolve this 20 cm to this side. We just do basic rule. So we bring this 20 cm to this side using cosine. So when we bring it to this side, we add. We know that the value here will also become the value here, right? So we add them together. So when we take out this part of the triangle, when we know that here is opposite and here is what? The hypotenuse. So the relationship between the opposite and the hypotenuse is sine theta, right? That means that sine 15 is equal to opposite over 20 cm, right? And the opposite is what we are looking for, because that is where the distance between the charges is located. So opposite becomes 20 times sine 15. So 20 times sine, we're getting it now, 15 is equal to 5. We're getting it now, from 5.18 cm. So what we do is that since they are two, because this distance between there are two opposites, so we add the two together, or we multiply this by 2. So this times 2 here will give us 10 point, are we getting it now? 35. So it gives us 10.35 cm. 10.35 cm. So this is in cm. We divide by 100. And if we divide it by 100, that is 10.35 over 100. Divided by 100, we have here is equal to 0.1035, right? Okay, so if that is true, we now have what? The distance. So we can now use our normal Columbs law to say F to be equal to K. I'm getting it now. Now Q1 and Q2 are the same, so when they multiply, they square themselves all over arrow square, right? So we make Q the subject of formula just as what we did just now, become F arrow square all over K, all in square root. So that becomes F, as we have calculated for. F is what? 3.9999 times 10 raised to power minus 6. Arrow is 0.1035, and K, constant of proportionality. You know that K, the constant of proportionality, is 9 times 10 raised to power 9. So if we press your calculator, Q here becomes 2.18 times 10 raised to power minus 9 coulomb. Wow, that's the answer. Very, very easy. Thank you for watching. If you want me to do the other examples behind, you can comment it. If I see some comments, I will see how I will do them, but because of time, I want to meet up with the semester. We'll be going to chapter 2 next time on the video. Thank you very much for watching. Make sure you like, subscribe.